I will show you how I did this experiment. Okay, firstly, for length, okay, we tabulate our data in this table, and then this table I will show you later on Excel how I will obtain this automatically without using calculator. Okay, and also for the resistance, we tabulate the data and we will get this also in Excel. Okay, so let's go. Put the data in this column. Okay, and then at the bottom of the column we search for the average. Just type equal average and the range we want. Okay, for this column we want the length in SI unit, so the data we get we divide by 100, and then I generate it to all of this column. Okay, for this column it was the length of data minus the length of average, this. Okay, so the formula is like this. It was minus, so I put this formula and generated for all of the column. Okay, for this is actually this value we squared, and then the formula is like this, and then I generated to all the columns. Okay, for this is actually the sum of all, and we divide by 7. Why 7? Because it's n minus 1 according to the formula. Our n is 8, so we minus 1 is it will be 7, so we get this. And for this we just use standard deviation and the range that we want to standard deviation it. So the range is the data. Okay, for this, as you can see, for the formula it was standard deviation divide by square root n. The square root n is 8, so I wrote the formula like this. Okay, for the diameter, for the resistance, I use the same method. Wrote all the data here, and then for this part is minus resistance data that we get minus the resistance, average resistance. Okay, and then I put the formula to add here and generated all the columns. Okay, for this also we square root this formula. We square this formula, and I put the formula and generated to all the columns. And this is the sum that divide by 7. Okay, for this standard deviation I put STDEV, and then this. Okay, for this also this is standard deviation divide by square root 8, so just like that.
So now we are going to proceed to the next part, which is the sub-experiment 3. The objective of this sub-experiment is to measure the diameter of copper wire and also estimate the related error. In this experiment, we use micrometer as our measuring apparatus because micrometer has a smaller scale division of 0.01 millimeter, and it is very suitable to measure tiny thin objects. Before we start our measurement, we remove a small part of enamel coating of the wire until the bare copper is observed. Then only we measure it using our micrometer. We repeat the measurement 8 times so that we can get 8 readings, and our data will be more accurate and also consistent. After getting the data, we calculate and estimate the related error of the diameter. The table shown is our table after getting the data. Before we start our measurement, we found out that our micrometer have a zero error with a 0.05 millimeter, and the data in the table here already include the zero error, which means that we already plus the 0.05 millimeter with the initial reading. Next, we calculate the sample size and also the average length of diameter. And the table here shows that our reading of the diameter, we use the reading to calculate the variance, the standard deviation, and also the standard error.